Okay, so let's talk about milestone 2. How many of you started on milestone 2? Okay, a little bit. Far? How far are you in? Okay, how about the rest of you? Started anything? You got the intersections going? Okay, so you're kind of probably in a good place for this tutorial. So sounds good. Actually, who saw my Piazza post that you should update EasyGL? Do you guys see that? So it's a minor update. If you haven't made any changes to the files, it's just best to just get all the new files because I got a few useful tweaks. But the main thing is that they have disabled graphics working, which is important for the auto tester. So yeah, go do that. Okay, so let's talk some more about milestone 2. So where we ended off before reading week is we're setting a coordinate system that made sense. It was based on a projection of a city to meters on the surface of the Earth in XY coordinates. And we needed to make sure that we lined up the coordinate system we chose and our drawing. And we did that. So it worked well. This is what the code looked like. So we had this global variable called intersections. And in it, we preloaded the latitude and longitude of every single intersection. And then in our drawing callback, which we chose to call draw main canvas, this is our most important callback, redraws the screen. We basically went through all the intersections in a big loop. And we computed what is their x value by calling this function, what is their y value by calling that function, so project them to xy. And then we drew a rectangle that was 100 meters wide and 100 meters high at that intersection location. So we drew our map, it looked good. Okay, so this routine is speed critical. So part of what you're trying to do in milestone 2 is make your map feel responsive. And your redraw routine is the key for that. As people are zooming in and out, as they're dragging, clicking on the graphics and dragging them around, they get a lot of redraws, okay? If those redraws take, the longer those redraws take, the less responsive the map feels. So if you can redraw, you really would like to redraw multiple times a second. If you can draw 10 or more times a second, it's gonna feel pretty responsive. If you draw slower than that, it'll start feeling a little laggy. If it takes you like 2 or 3 seconds, it's gonna feel really laggy. So like to make it fast. If you can make it redraw 50 times a second, which is hard, feels even better. It's going to feel really smooth. So we want to make this fast. Is there anything we can do to make this faster? This code's perfectly functional, works fine. Well, let me ask you this. First, what's the order of this code? What's the computational complexity? Because if it's really low, then we don't have to worry about it. You just ignore it and we're done. So what do you think? Yeah, so it's order n. So we've got n intersections. We draw each of them. We do constant time work for each. So it's order n. It's hard to get away from that. You're supposed to draw this whole city. So pretty hard to draw it without looking at all the data. If you're really zoomed in, there actually are some techniques that can be below order n, but they're fairly complicated. We don't actually expect you to do them. Few teams might, but you don't have to. So generally, this is going to be order n. And when you're zoomed out, it's kind of impossible to avoid order n, okay? But we can lower the constant. So we're going to leave this order n, but can we lower the constant? Is there anything here that you could get rid of? Speed it up somehow. And I guess I'll give you a hint. There's no code you can just delete, right? All this code is necessary, but could I pre-compute some? Because we always call load map, right? This redraw function is called many, many times. Every time the window's hidden and revealed, many times when you're zooming in or zooming out or panning around, right? If you hit the mouse scroll wheel, you'll zoom in kind of a bit at a time, you'll get a whole bunch of redraws. So if there's something in here that we could compute and load map, we can do it once instead of hundreds to thousands of times, which is what's going to happen if we put it in our redraw routine. So what do you think? Is there anything here we can pre-compute? So we did already load this latitude and longitude in our intersections vector, okay? So that seems kind of good, right? We don't have to call streets database, so maybe that's helpful. Streets database is not that slow, so maybe we didn't have to do that, but probably doesn't hurt. Anything else we could do? Okay, so I'm computing this x and y, and I'm using x from lon and y from lat. Do x and y change for a certain map? So for Toronto, does the location in this map projection of Yonge and Bloor, does it move around? No, its latitude and longitude are fixed. The equations to convert it to a point on the surface of the Earth are fixed, so this X and Y will not change. Okay? We can zoom in and zoom out, but that's actually done by EasyGL. It keeps track of how to transform, your coordinate system to pixels. So that's all happening in fill rectangle. This is never going to change, okay, for every single intersection. If it was one intersection, who cares? But there are 150,000 of them in Toronto and maybe 600,000 or so in Tokyo. So we're doing a lot of computation of these X and Ys. And we don't actually have to. We could move it to load map. Does that make sense? Okay, so that's one of the optimizations you can do, is look for things in your redraw that seem like they could take significant time. Usually means they're in loops. And could you compute them in load map instead? Okay, so let's look inside these helper functions. And we'll see, well, how much work is in here. Should we do something about this or not? Because it's not worth optimizing everything, right? It takes too long. So you should always put a cost on your time. Okay, so what have we got? Let's just look at the longitude one. The latitude is similar. So we've got a multiply, another multiply, another multiply, another multiply, and one cosine. Okay? So we've got 4 multiplies and 1 cosine. We did this once, who cares? But we are doing it 150,000 times on every single redraw. So maybe that's worthwhile getting rid of. Okay, let's do a quick challenge here for speed. Okay, so I'm going to challenge your team to a speed race with their team. Okay, actually, you join their team too, okay, to be fair. So the 3 of you against 3 of you. Okay, who wants to go first? You can confer, you got to answer, and I'm going to time how long it takes, see who can answer faster. I'm going to give you one question, you one question. Do you want the first question or the second? Took too long. Do you want the first question or the second? First question. Okay, here's your first question. What is 2 times 2? 4. That was very fast. It's going to be hard to beat that. They didn't even confer, okay? Okay, here's your question. Cosine of 2. Wrong. But yeah, so do you feel these questions were fair? No, they were not fair. Okay, the reason I did that is multiplication is actually easier than cosine. Okay, so actually the biggest consumer of CPU time here is actually the cosine. All modern CPUs they can launch a multiplication every single cycle. It's one instruction. Some CPUs can do more than one multiplication in a single cycle if they're high end. Cosine is actually going to be like a Taylor series subroutine or an equivalent numerical method. It's going to be a whole bunch of mathematics to kind of work out a reasonable approximation of cosine. And that actually has to be quite accurate because it's like I think this one's a double precision number. So you can imagine, you can't kind of get it somewhat close. You got to actually have a lot of terms in that Taylor series. So this cosine is actually the slowest thing. So you want to at least, basically right now, we're doing this cosine like 150,000 times every single redraw, and it's the same number, okay? So it's pretty wasteful. We could just store that in load map. But we may as well just go a little further, and we're just going to store the whole thing, okay? But watch for this. If you're doing this cosine over and over again, instead of storing just the average latitude, also store the cosine of the average latitude. You'll speed up your redraws. And it's not a lot of code. Sorry, did you have a question? It only does radians. Yeah, it's written to take radians. If you pass in degrees, you just get the wrong answer. Does that make sense? Okay, so this is wasteful. So we're going to move this code to load map, and it's not very hard. So instead of storing, I'm going to change the structure, and instead of storing the lat long of an intersection, I'm now just going to store the xy. I'm going to just pre-compute the projection to xy. I'll store that. I don't even need to store the lat long anymore because I actually don't need it. And I put that in a global variable that I can use in my redraw function. My redraw function doesn't change much. It actually looks simpler. Okay, it just goes through and it just gets the XY location, uses that as the lower left corner of a rectangle, and says make it width and height from there and fill it. Okay, so there are a bunch of different ways you can call fill rectangle. A bunch of the EasyGL functions are kind of overloaded for convenience. There are different ways. So I'm calling it in a slightly different way. 1 point and a width and a height. And this is a data type that's defined in EasyGL, 2-dimensional points, just got a .x and a .y. It's what the rectangle fill rect takes. So I'm just directly pre-building that to kind of make things as fast as I possibly can. I'll put it right in the exact right kind of data so I can just pass it to fill rect. Okay, so it makes sense. So look for opportunities like that to bring the constant down on your redraw routine. And let me just go and demonstrate that. Let's see where I put it. Okay, so let me build this. Let me just remind you of what this looks like. Okay, so this is this drawmap function. I gave my drawmap kind of different names, but yours is probably just called drawmap. And we computed the minimum and maximum latitude so we can get a good coordinate system. I should use helper functions. So I put this in a helper function now. So and you should do this too. So I've got a helper function that goes through all the intersections, finds the minimum and maximum latitude and longitude. And now I put another loop in it. So the second loop goes through. And now that I know my average latitude, it just goes through and it pre-computes all these XY locations for every single intersection, and it stores them. Okay? And I also stored their name because I felt like doing that too. Might need that as well later. Okay, so that is what I pre-computed. You saw this before reading week. You know, we have to set up the EasyGL application, so I'm doing that. I set my coordinate system with this world that I just created, and I say, what is my redraw function? So this is the name of my screen redrawing function. And then I pass control to EasyGL with this .run call. And EasyGL can take more callbacks to do additional things. I don't want them right now, so I just pass in no pointers. I go look inside this redraw function. It looks just like what I said. Okay, it just goes through, sets the color to black. So EasyGL has multiple ways to set colors. You can set RGB, or you can use some predefined names. Here I just decided to use a predefined name. And then I go through and I draw all my intersections with fill rectangle. And I added a little bit more code, which is the code I showed in lecture to time things. So I say, give me the start time, give me the end time or current time, and print it out. So basically my redrawing function is going to time itself. So every time it's called, it's going to tell me how long it took. I get the time at the start, I get the time at the end, I print the difference. Okay, so let me run this. Okay, so it looks fine. And it tells me how long, I can see down here, let me highlight this, it's telling me how long it took in the screen redrawing. So let's, okay, so let me just show you how many redraws you can get. So I'm going to basically drag the graphics around now, and you see there's a lot of redraws. You see there's just like all sorts of redraws going around there. When I zoom in, I get a redraw. Actually, I zoomed in a few times. I don't have a mouse scroll wheel, but if I had that, I can zoom in with lots of redraws and so on. Okay, so let me zoom fit to draw this, make this big again. Okay, so let's watch more carefully the speed. So I'm going to drag this around. You see, it takes about 0.006 seconds, which is pretty fast. So if I wasn't going to draw anything else, I should just say I'm done. Right? It's more than 100 times a second. That's great. But I am going to draw more stuff, which is why I'm showing you how to optimize it. Like I haven't drawn streets yet and so on. So it is going to slow down. As I zoom in, just watch what happens. It's actually getting faster. Okay, so it's basically now down to about 0.0012. So it's about 5 times faster than it was when I was zoomed out, if you notice that. Okay, so it's now about, it's a little more than 1,000th of a second. So why do you think it got faster? Because I didn't change my code. Let's go back and look at my code here for the redraw. This redraw does not check the zoom level, does not do anything different. Okay, it's the same code every single time. So why is it faster? Any ideas why it got faster as I zoomed in? Yeah, so I'm making the same number of calls to fill rect. Fill rect is getting faster. So drawing actually pixels takes a reasonable amount of work. EasyGL does what's called pre-clipping. Okay, so it basically, as soon as you call any EasyGL drawing function, the first thing it does is do a bunch of fast checks to see, can I prove this is not on screen? Okay, so it basically checks for this rectangle, is the whole thing to the right of your right window boundary? Is the whole thing to the left of your left window boundary? And same for the top and the bottom. Okay, so let me show it to you again. And basically, if a rectangle fails any of those tests, it's for sure off screen, and basically it doesn't actually call the underlying GTK and Cairo and X11 libraries. There's basically like multiple layers underneath this now. And they're actually, so basically it's faster. You don't have to do pre-clipping because EasyGL does it for you. Okay, so you will naturally get faster as you zoom in. It's just going to happen. Does that make sense? Okay, so let me close this down. And let's go back here. Okay, so I'm not going to show it, but I also measured the code we had before reading week that didn't do this pre-computation. And when I measured it, it was on a different computer, so the numbers are slightly different. But basically, the old code took 0.02 seconds to draw when the whole map was displayed, like we're zoomed out. And it sped up by a factor of 1.5 when I did this pre-computation. So it was worthwhile. When I'm zoomed in, it actually sped up by more, 2.1x. The reason I get a bigger speed up when I'm zoomed in is basically fill rect is getting faster. So the overhead of me just going through and doing these computations is kind of a bigger percentage of my work. So speeding it up has more impact. So this was worthwhile. You know, well, if this was all my drawing, it wasn't worthwhile because it was already fast enough. But if there's other stuff, this was worthwhile. The biggest gain is going to be the fact that I'm not doing that cosine over and over again. So if you do one thing, that's a good thing to do. Okay, so does it make sense? Okay, so that's it for speed up. So that's one of the ways you speed up your graphics. Just look for opportunities to preload. Another way you speed them up, which is actually your biggest hammer, is level of detail modeling. So I talked about this in a lecture on Monday. If you are zoomed way out and you are drawing everything, first it's going to be slow because everything is on screen. It all draws. So you're going to feel pretty non-responsive. And you're probably annoying the user anyway. Like there's no possible way that a person can actually visualize 150,000 streets. So you're drawing tons of stuff that is just a noise. When you zoom in, you want to be able to see the details. But when you're zoomed out, you can just drop the details. And that's one of your challenges. If you drop it, you can make things a lot faster and less cluttered. You can also have buttons on the right-hand side where you can turn on and off features. So you can basically give the user choices. Do you want to see this or do you not want to see this? That's another way you can kind of speed things up. But you will not be able to make it very responsive if you say, I'm just always drawing everything and I'm going to try to micro-optimize my code. So I've shown you some techniques you should use, but yeah, it's not going to be enough. You got to do level of detail modeling or have some controls to turn on and off things or both. Does that make sense? Okay, so that's what I was going to talk about for drawing. There are a few things like if you draw thin lines, width 0 lines are 100 times faster than width 1. Even though they both draw as 1 pixel. Width 0 just basically is allowed to take a few shortcuts. And those shortcuts matter because it like looks almost identical, but it's way faster. So there also are some differences like that. Certain things render faster than others. But before getting too much into optimizing that, you want to learn, you want to basically put timers in, like what I just showed you, because you could spend a lot of time trying to optimize things that don't matter. Next tutorial, next week, I'm going to show you some other techniques to time and profile your code so you can get more information on where do you spend your time. And those are generally useful things to know about if you're just for your whole career. Okay, so that's it about drawing. Now I want to talk about responding to user input. Okay, so first let's talk about mouse clicks. So in that code I just showed you, we called application.run, hands controlled to EasyGL, and we had null pointer for all 4 arguments. Now I'm going to set the second argument not to null pointer. I'm going to give the name of a function. Okay, this is the name of a function that I write. So I'm going to call it act on mouse click because the second callback, these are all callbacks basically. You can register 4 additional callbacks with EasyGL if you want to. The second one is the function that will be called when the user clicks the mouse button anywhere inside that main canvas, the place where you're drawing your graphics. Okay, so and basically you just give it the name. So the name connects it. The function you write can be called anything, but it must take the arguments that EasyGL expects, which is an application pointer. So the EasyGL application pointer is sent to you. That's so that you can call EasyGL functions. Otherwise, it might be hard for you to do things. You're also passed a pointer to the event, and you can look up online what's inside this data structure. Basically, if you want to, you can look inside there and it'll tell you, is it the left button? Is it the right button? Was shift held down? Was control held down? So you can get some extra information because maybe you want to do different things based on which button it was. And then the most important thing is you're told the X and the Y. So where did the person click? This is in world coordinates. So with the coordinate system we chose, meters on the surface of the Earth, that's what you're going to get passed back. Okay? What we want to do is actually a good idea for your callbacks, at least until you do your final submission, to tell you what's going on. So I'm going to have my callback print out where was the click. And then we want to find the closest intersection. And I want it to print out the name of that closest intersection. And I'm just going to print it to the terminal right now. Okay? How do I find this closest intersection? So I've just got an XY location. How do I find the closest intersection to it? So what do you think? I didn't leave much space for code. So there are multiple ways to do this, but one of them at least is going to be short. Okay, so think back to milestone 1. For milestone 1, the main purpose is just a learning exercise, learning how to use different data structures, how to read an API, how to use unit tests. But a bunch of those functions also are crafted so that they'll be useful to you in future milestones to kind of spread out your workload. So is there a function you wrote in milestone 1 that seems like it might be useful? Because there is one. This is a big hint. Just think back. There's got to be one. All right, so there was a function called find closest intersection. Okay, you passed in a lat long, and it returned the closest intersection. It returned the ID. So it does almost exactly what you want. The only thing that's wrong is it takes a lat long, and we don't have a lat long. We have an XY. So what are we going to do? Well, we could just write a new version that works with XY. Okay, we have all the XY stored, so we could write a new version, and that's okay. We could do that. I'm going to do it in an even shorter way. Basically, we can write functions that just map from XY back to lat long. Right? We already wrote helper functions to go from lat long to XY. All of you know far more math than you need to just invert those little functions and do the opposite transformation. So either of those techniques will work. I'm not going to show you the helper functions. They're not very hard. But basically, I have a couple helper functions, compute a latitude from a Y, the longitude from an X. And then I take those two things and pass them to the lat long constructor so they turn into a lat long. I store that in an object, and I pass that object into my M1 function. All right, and it's going to come back with the ID of the intersection. So I didn't show you the helper functions, so you got a few more lines of code to write, but it's not a lot. Make sense? This function, find closest intersection, is also order n. Okay, you might not remember that, but well, you can write it in different ways, but we basically put an easy speed test on it or no speed test. So most people are going to write it as order n. Do you think that's going to be a problem? So I said for your screen redraw function, we just optimized it and it was order n. This function is also order n. Should I do any additional optimization? Or should I just go no? Because you got to put a price on your time. So the answer about should you optimize or not is often no. Even if you could optimize it, you should not do it. Because there's a cost to your time, there's a cost to making code that's more complicated and harder to read and debug. So should we try to make this faster than order n? Okay, so I'm your keener teammate. I'm like, we got to make it faster. I read about these data structures. There are data structures called KD trees and R trees. They're like two-dimensional versions of binary search trees. They could do it in log n. So it is doable, right? Divides up the space, does comparisons, finds this thing really fast. Should I write that or not? Okay, so you're shaking your head. And you're right, we shouldn't. Okay, unless you're just bored, right? You're just kind of like, this is all so easy, I need a challenge, whatever. Then fine, go write it. But otherwise, don't write it. Why? Why should I not do it? So one reason is, yeah, you're busy, but am I going to get any value from that at all? You're not. Why am I not going to get value from it? And you won't. There's no value to writing that. So why is there no value to writing it? It is faster, right? It could be log n instead of order n. But it does not matter in this function. Why does it not matter in this function? Does this function have to be really fast? Yeah, what do you think? Yeah, you can make it somewhat faster, but how fast can a person click the mouse? A person cannot click a mouse really fast and interpret the results. So your response to mouse clicks, unless you do some weird stuff, is going to be limited by how fast a person can actually click on things and read the response. So optimizing the speed of your redraw function makes sense because you're going to redraw a lot of stuff and you're going to do it often. And people do notice if the scrolling is draggy or not. unless you did put like order n squared code or something in this respond to mouse click, they can't tell because they click and then they kind of look to see what the heck happened. And if that happens in like a 1/5 of a second or a 100th of a second or half a second, they can't really tell. If it took 10 seconds, okay, now they're going to tell. But this is not going to take 10 seconds, okay? So yeah, don't optimize this one. So you got to be careful about, like, spend your time wisely. Don't just go and write everything in the most complicated way. Okay, so I now know I found my intersection, I printed it out, but I'm supposed to do more. I'm supposed to highlight this in the graphics. How am I going to do that? So what do you think? What should I do now to highlight this in the graphics? Any ideas? Okay, so let's say I want to draw it in red. Whatever intersection you clicked on, I want to draw that one in red, all the other ones in black. What should I do to make that happen? Okay, so I'm going to give you a proposal. Okay, EasyGL has these functions to set the color. I'm going to get the syntax a bit wrong here, but you get the idea. So set color red, and then fill rect of ... Figure out the right thing. Okay, figure out the coordinates of that ID and draw it. What do you think? Look good? Anybody like this code? Anybody not like this code? People are quite ambivalent about this code. So I can take it or leave it. So what do you think? Who likes this? Okay, so a couple people like it. Who doesn't like this? Thinks this is not the right way to do it? Okay, 4 people are like, I'm not really sure. I got no strong opinion. I mean, it's better than nothing, but this isn't actually the right way to do it. Okay, the reason this isn't the right way to do it is I put these drawing calls in here. And it will actually draw that intersection in red. So that sounds great. What's going to happen when the person zooms out? Okay, screen's going to get redrawn. You're going to lose your highlighting. What's going to happen if the person just, clicks on the graphics and moves them over a little, right? So they pan. Again, you lost the highlighting. If they hide the window and reveal it, redraw. Lots of things cause redraws. Okay, so if you put your drawing code in here, it's not persistent. And people do not expect that. Every year we'll have a few students who do it this way, and some of them will argue with their TA. This is a user interface choice, right? You click on it, it stays there until you redraw the screen. No program works like that. Like, think of Microsoft Word, you typed your text and it was there until you redrew the screen. And once you redrew the screen, it threw away your document. And Microsoft argues, well, this is like a user interface choice. Maybe you only wanted to see your text until the screen redrew. Like, that's not a logical. There are many choices of user interface, but this is not a logical one. So don't do it that way. Yeah. Sorry, can you say it louder? Yeah, so you can print it out. We did print it out. So that will be in the terminal. But if you look at the rubric and the instructions, it says you should highlight it. So you highlighted it briefly, but then it disappeared. And yeah, you won't win the argument with the TA, right? The TA is going to go, no way. So that's not a user interface choice. Okay, so what can I do? I want it to be persistent. I want what's called stateful graphics. Like, this should happen not just once, but for all the redraws ever. You highlight it, stays highlighted until you decide that it's not highlighted. Okay, but you should decide when that happens. Not on a redraw. It should be, I don't know, when you hit a button that says clear highlighting, or you click on a new thing or something, right? You can decide that. Lots of logical choices for that, but not just it disappears on a redraw. So how can we make it? We need it to be there every time we redraw. How can we do that? Any ideas? So I guess the name should give you a hint. Stateful graphics. So we're going to need state. Okay, we have to store information. Yeah, otherwise we can't make the redraw do the right thing. So, okay, so what are the steps to highlighting an intersection when it's clicked? So we need to register a callback function so that we get called when there's a mouse click in the graphics area. We already did that. We need to write the callback function, and it's going to have to find the intersection closest to click. We already did that. Okay, so I already did this piece. Whoops. So we already did this, and we already did that. Draw it. Yeah, don't draw it. You have to record that it's highlighted instead. And now your redraw function should be modified so that it looks at that highlighting information and it changes how it draws the screen. Now your highlighting is persistent. Doesn't matter how many redraws you get. Does that make sense? Okay, so how do we do that? There's multiple ways to do this, but like maybe this is too vague a question. I'll just show you how I did it. All right, so I already showed you this, but basically we have to register the callback. So we give the name of the function that we want, and that function has to have the right signature. And it's the second argument to this run that is the mouse click callback. Just for completeness, the 4 callbacks that are optional that you can pass to EasyGL is, first one is called, when you set up the graphics, it's called once. So if you want extra buttons or extra UI elements, you put the setup code there. This one we just talked about. There's another callback that gets called not when the mouse is clicked, but when the mouse is moved. So it's called a lot. You can use this if you wanted, for example, show tooltips. Like you just hover the mouse over something and you show some information. But you don't have to use it. So if you like that, you could do it. Otherwise, ignore it. And this callback is called whenever the keyboard is hit and the mouse is in your graphics area. And it'll pass you what is the key that was hit. So you can use that to do other things too. Have you guys, do you know how these, how do we, some of the students are confused. Like, how do we pass a function to a function? Like, it seems weird. This is a function, and I'm passing a function to it. Like, what does that mean? Do you know how this actually works in the C++ compiler? Okay, so in 243, have you learned about like the branch to subroutine or jump to subroutine instruction? I can't remember what ARM calls it. Is it jump to subroutine or branch to subroutine? Branch to subroutine, okay. So it just goes to a certain memory address. It starts executing code from there. That's actually what a subroutine is. So what the C++ compiler is doing is it is basically this name, what it actually sticks in your program is the address at which the instructions for that function starts. So EasyGL now knows the address of that function. Doesn't know what you put there, just knows start running instructions at this address. Whenever the mouse is clicked, it's going to say branch to that subroutine, okay? And it's going to do something. This is why you also have to have the right function signature, because it's going to push all the arguments on the stack that that function is supposed to take. If you don't take those arguments, life is bad, right? In fact, the compiler won't let it compile, but it's doing you a favor because it would be chaos. You would just have your program would crash in horrible ways. Okay, so that's what's actually happening here. This really means memory address, and it's being stuck inside the EasyGL program, so it knows go call that subroutine. Okay, so we've registered the callback. We write the callback function. We already wrote all this code, so that's fine. We have to store who's highlighted. There are many ways you could do that. What I've chosen to do is in my intersection data. So I've got intersection data for every single intersection, right? There's this global variable. For the intersection that you selected, so this one with a certain ID, oops, let me circle in the right spot. That ID I just set its highlight to be true, okay? Now I know it's highlighted. It's stored. And I should initialize this highlight for every single intersection to be false, because it makes sense that initially nothing's highlighted. It only highlights it when you click on it. Sometimes students are tempted to put this in the constructor, or the initializer. So they might be tempted to go like that. There, I've initialized it to false. It's not going to break your program, but it's not going to do what you want. How many times, if I write equals false there, that basically initializes the variable when it's created. This is a global variable. When is it created? So basically this is created, well, this particular one is going to, every entry in this will be created in my load map when I do like resize and so on. And you want to be careful that you make sure the way you code this, that this is always set to false every time you do load map, okay? So to be honest, this one will probably work now that I think about it, because it's, as long as you call resize, then it'll be all right, because the resize is going to reinitialize every vector. But basically be careful about initializing global variables and assuming that they're the right state, because generally you have to reinitialize them if a new map is loaded. So make sure your load map sets everything up. Don't rely on like initialization in the constructor of your global variables. Does that make sense? Okay. So our mouse redraw function, our mouse click function is now storing this highlighting information, and our redraw function basically looks at it. So all it does is it basically is the same as before, go through all the intersections and draw them, but it now does a little bit more. It checks, is this intersection highlighted? If it is, it draws it in red, otherwise it draws it in black. Okay, and otherwise basically the same. So let me go and show you what this looks like. Okay, so let's take out the all right, so there's my map. I'm going to zoom in a few times so you can see the intersections better. Okay, and let's say I click on this intersection. All right, so it printed out. You can actually see I clicked on it. If you look down at the bottom, you can see that the mouse click is at a certain location. The lat long is this. The closest intersection was 9131, but nothing turned red. Okay, so I did click on something. My mouse, this is why it's good to put printouts in your callbacks. You can tell your mouse callback was called. What happened? It found an intersection. It's not highlighted. Okay, so that seemed kind of weird. Let's click on another one. Okay, that one's not highlighted either. Okay, I'm going to just zoom out a little bit and think about this. But I zoom out and now I see something highlighted. Okay, let me click on this one. Nothing shows up. But if I move the graphics over a little bit, now it shows up. Click on that one, nothing shows up, but now it does. Okay, what's going on? Yeah. Yeah, I'm not forcing a redraw. So basically, I have marked that it's highlighted, but the user can't see that until a redraw. So this is also very user hostile. There's no immediate feedback. So how can we fix this? So we're going to do something. Again, you're not going to be able to argue with your TA that this is a logical decision. There are lots of things where you can say that's my design decision, but this is not one of them. So what are you going to do? How do you fix this? Yeah, so I do need now I need to do some drawing in my mouse callback. I could basically now say, fine, I'll put in the drawing code for that one intersection, but that's not really the best way to do it. The better way to do it, because I don't want to duplicate code, and there can be a few other issues with that, like making the graphics actually show them, because yeah, graphics APIs are allowed to sort of buffer up graphics. So there's a couple issues. You would wind up, if I just draw this intersection in red in my mouse callback, I've duplicated some code, so that's not that nice. And you also have to make an extra call to tell the graphics library, I really want to see the output now, because they're allowed to buffer things up for efficiency. So what you do is you make this call. This EasyGL application class has a refresh drawing member function. It will force a redraw to your screen redraw function, so you don't duplicate any code. And it tells the graphics library, I really want this to show up right now. No buffering, okay? Well, buffer for a while, but now you got to show it. So that's going to make it highlight right away. I'm showing a little more change here as well. So right now I'm printing the intersection ID to the terminal. So it's useful for debugging, but this is not very user-friendly. I should first probably print the name, not the ID. And if I can print it in the graphics, it's going to be nicer than printing it to the terminal. So I think you guys learned string streams in 244. Is that right? Okay, so I just basically, I want to make a string that has, the information that I need in it. So I make a string stream. I basically put this text in it, intersection selected and its name. And then string streams have this .str member function. If you don't remember this, you go to c++.com, you look it up. Like, I don't remember the names of these things either. I look it up all the time. And so I can get the string that I just created. I can pass that to an EasyGL function called update message. EasyGL has a single line of text that it can display in a little status bar at the bottom. That's the way we set up the UI. So to show one line of text at a time is really easy. You just call update message. So I'm going to do that because it's simple, and it's going to give me a nicer display. Okay, so I'm going to discard that. Okay, so I'm going to switch to my next demo. But basically, the code's not much different. It just has that little change that I showed you. If I run this, and make that bigger, zoom in a bit, go maybe closer to campus. And actually, I'll go to High Park. Okay, so I just clicked on something there. I'm going to do this again. Okay, so I'm going to click on this intersection. I click on it, it shows up right away. Okay, click on this one, shows up right away, click on that. And notice that it says Colborne Lodge Drive is selected. Might be hard to see if you're far away, but that little text, there's basically one line of text that's built into the GUI, and I'm using that. So now I'm getting more information to the user. So it looks pretty good. But let me show you one thing that's a little bit annoying still. Okay, so I'm going to zoom in a little more. Okay, so if you can see where my mouse cursor is right now, it's kind of in this. It's in a certain intersection. When I clicked on it, I got the one next to it highlighted. Okay, so that seems kind of weird. Let's try that again. Okay, that one worked okay. That one got the one next to it. Okay, so kind of getting an intersection nearby, but not always the one I expect. Sometimes it's the one I expect. Sometimes it seems like it's off by one. What do you think is happening? Okay, so my selection doesn't seem perfectly accurate. Any ideas? Okay, so we're using find closest intersection. Where is the intersection? What is so I'm drawing a box, but where is the actual intersection? If you remember how I was drawing these boxes, I'm drawing them from the lower left corner is where the intersection is. And then I'm going to the right 100 meters and up 100 meters. And I'm drawing a box there. So the actual intersection location is at the lower left corner. And that's actually what I'm getting. If I'm closer to the lower left corner of this one than this lower one, it doesn't matter that I'm inside the box of the lower one. It's just checking what corner am I closest to, okay? So this seems a little annoying. How could I fix this? Actually, multiple ways to fix it, but what do you think is a good way to fix this? What's the easiest way to fix this? Basically, the problem is coming from the fact that what I'm drawing and how I'm doing selection don't quite line up. They're kind of close, but they don't perfectly line up. Right? I'm drawing a box from the lower left corner is the intersection, and then I'm going up and to the right. And then when I click on things, I'm just saying, what's the closest intersection? Which is really, what's the closest lower left corner? And that's kind of not very intuitive to people. So what do you think I could do to make this better? Okay, so the easiest thing to do is I just draw the box centered around the intersection. If I draw it centered around the intersection, then my find closest intersection is going to, basically whatever box I'm closest to the center of when I click is going to be selected. And people are going to find that a lot more logical. Does that make sense? I could also do things like find the closest intersection. And then after I've done that, check, am I inside the box? And if I do that, now if I'm not in any box, I won't select anything. Maybe that's even better. Okay, and that wouldn't be much additional code either. So I could do either of those things. Those are both logical. So let me go back and I'll just show you what the code changes. It's pretty small. So yeah, so I want to change this. I'm basically just going to shift my rectangle. This code, there's lots of ways I could write this, but I'm basically making a point and subtracting it from my original point. So I'm basically shifting my lower left corner down by width over 2 and height over 2. And now basically the intersection is in the middle of my rectangle. And if I do that, my selection is going to look a lot more logical. So let's go look at that. Okay, so let's get this one out. Okay, and now if I go look at this, you're going to find that it works pretty well. Okay, so now whatever I click on, I'm kind of getting the right thing. It always looks like logical to me. Okay, so that was a pretty small change. Sometimes you notice that, let's see, you notice that sometimes the intersection is partially hidden by another one in front of it. If that bugs me, what could I do about it? I could decrease the box size. That'll probably help. What if I said I always want to see something highlighted with nothing in front of it, no matter what? Which could be difficult to guarantee just by decreasing sizes. So I could use drawing order. Right now, I just draw the intersections in order, but I could make 2 loops. First loop goes through and draws everything that's not highlighted. Second loop draws the things that are highlighted. Now highlighted is always on top. Or I might decide maybe instead of like having a highlight for every single intersection, I'll just have a vector of highlighted ones. And after I draw everything, I'll just draw the highlighted ones again. So if you want some things to show up on top, just draw them last. So you can control your drawing order. And that's a very useful technique. You're going to use that some in this milestone. One last thing. Okay, in this user interface, how do I deselect things? So right now I can click on things and everything I ever click on will be highlighted. Do you think your TA is going to have any issues with that? So you need to come up with some way to dehighlight. And it's up to you to decide what. Maybe you click on the thing a second time and it dehighlights. Maybe you click outside any box and it dehighlights. Maybe you got a button that says clear all. Maybe you only have one thing highlighted. You click on a new thing and the old one is dehighlighted. Do something, okay? You can check the buttons, you can check in your callback, is shift held down? So you could even have, if I'm holding down shift, you just add it. But if you're not holding down shift, you clear all the other highlighting first. So you could do all sorts of things. But just do something. Don't leave it with no ability to clear it. All right, so let me quickly try to finish off the last couple of things. Okay, okay, so we just showed how to do a mouse callback. You also are probably going to want to add some buttons, so some additional user interaction. There are a couple different ways to add buttons. If you want to add buttons that look just like the EasyGL buttons, then we basically make some simple calls for that, and that's what I'm going to show you. If you want to make UI widgets, which means stuff, search bars, choosing menus, all sorts of things, then you go to GTK. That's completely optional. You do not have to do that. If you do any of that, it's considered an extra feature, all right? There's kind of a how do I get started on that in the EasyGL Quick Start Guide, and then you have to do some more reading online. But if you're just like, I'm busy, I don't want to do it, that's totally fine. It's completely optional. Okay, but I'm going to show you how do you create buttons the easy way. So there are 3 steps. You have to create the button in your initial setup callback. So you're going to have to register that callback. Then in your initial setup routine, which you're going to have to write, you're going to create the button by making an appropriate call. And when you create that button, you're going to attach it to its own callback, a function that will be called whenever it's clicked. It'll be called automatically by EasyGL. And then you're going to have to make your screen redraw do something. Okay? So I'm going to make the background turn pink when a person clicks on this button. And if they click on it again, the pink background goes away. So I'm going to have a global variable called pinkify, which if it's true, my redraw function draws the pink background. Otherwise, it doesn't. Okay, so first thing, set up the callbacks. So I now need to set up this initial setup, and I need to write it. My initial setup callback's really short. I'm just going to say, create me a button, call it pinkify. I want it to be in row 6. So the first row is 0. I want it to be in row 6. And I want you to call this function whenever it's clicked. Now I need to write that function. That function has to take this signature, takes the EasyGL application pointer, because without that, I can't do much. And it also takes a pointer to the GTK widget, which I'm going to ignore. I don't need it, but I'm going to get it. It's passed to me in case I need it. I don't need it. All I do in this is there's a global variable that I've made called pinkify. It's a bool. If it was true, I make it false. If it was false, I make it true. So it's just a toggle. And then I basically force a redraw. Okay? Last piece of this is my redraw function. Well, I guess here's my global variable. So I made this global variable so that I can store my state. And my redraw function basically just at the very start gets this additional code. If pinkify is set, I want to draw a rectangle that covers the whole graphics area. It's not clear how big that is. I can't hard code it. So what I do is I call get visible world. This will return a rectangle that is the size of the whole graphics area in world coordinates, the coordinate system I chose. So I just take that rectangle. Well, first I set the color to pink. This turns out to be pink. And I basically say, okay, fill that whole rectangle. And that rectangle I know fills the whole graphics area. And then I would do all the rest of my drawing. So I did this first, so it's in the background. Everything's going to draw on top of it. Okay, and let me basically quickly show you what that looks like. Let's see. Okay, so let's save and build this. Hey, are you coming in? Oh, yeah, it's going to be a couple minutes more. It just sure. Let's see. So, okay, so you can see I've got this new button, Pinkify, and it is in row 5. So there's row 0, row 1, row 2, row 3, row 4, row 5. Sorry, it's row 6. If I click it, my background turns pink. Click it again, the background's not pink. If I zoom in, it stays pink. Zoom fit. All right, so it took me not much code, and I've completed the Pinkify button. Pretty easy special feature. So those are the steps for that. And then the very last thing I was going to show you very quickly, let me go back here. Okay, so the last thing you can do, which again is completely optional, is modify the GUI. So the GUI layout is specified in this file. It's in your resources directory. So you put code in source, you put data in resources. You check it into Git if you put any data in there. We've already given you a UI layout called main.ui. You can edit it by using a tool called Glade. And I'm going to show you how to do that. And again, this is optional because it'll be a special feature if you decide to do this. And you should carefully think about whether you have the time, right? We let people do this because some want to try it as a challenge, but you definitely do not have to do this. Okay, so let's go here to libstreetmap resources. I'm going to check out the old main.ui. All right, so it's actually human readable. So this might be hard for you to see, but it's an XML file. You could edit it by hand, but that's a pain. And you notice that the name of this whole program is EasyGL application example. Okay, so we've got kind of not a very nice name for your program. And when I run this, you'll actually see that. So if you look in the top of that window, you see it says EasyGL application example. And this is on the marking rubric. The TAs are going to check, did you give it a more reasonable name? Okay, so that is one thing that you do want to change about the UI. You don't have to change anything else, but change that because it's a stupid name. Pick some name that makes more sense to you. Let me quickly show you how to do that, and then I'll get out of here. Let's see. Okay, so I could directly edit the XML, but that's kind of painful. This, I just typed Glade main.ui. Glade is the user interface editor. Basically, the main window is the whole thing. I'm now expanding on the left all these user interface elements that we created for you. This thing called the inner grid are the buttons on the right-hand side. You can click on the buttons. So you can basically edit the properties of the UI here. You could delete all this, you could change it, you could do anything you want. The one thing that you should do for sure, so I click on main window, you can see the EasyGL application examples over here on the right. I turn off this client-side window decoration, I can change this name. So I'm going to change it to awesome map. Save that. Okay, and get out of here. And now if I run this program again, it basically changed the name. Okay, and you can do anything you want here. So this is how, if you want to, as an extra feature, you can make new UI elements and so on. You create them in Glade, but then you have to write the code to hook them all up. So there's a mix of those two things. The EasyGL Quick Start Guide gives you a bit of information to get going, but if you decide to go further with GTK, you'll have to do a lot of reading on your own. Okay, so that's everything for today. Thanks, everybody. And I will get out of here. Sorry about this. You're welcome. Good luck with it.